Okay, so my name is Binyamin Rubin. I'm a postdoc here at the Electric Propulsion and Plasma Engineering Lab at Mechanical Engineering Department at CSU. And we work mostly on electric propulsion, which is advanced propulsion for spacecraft. It's being used on many satellites, on interplanetary deep space spacecraft.
This is the thruster, and as you can see, the blue kind of loop is the actual plasma current loop that we were trying to measure using the magnetic sensors. And that's where the electrons are trapped, and with that blue, this blue that you're seeing is like really the plasma that's kind of being output, and that creates the thrust for the thruster.
So we don't want to interfere into that plasma discharge. We want to do non-contact measurement, and that's what we are doing. We're using magnetic sensors that can measure the magnetic field produced by the current in thruster, in plasma. And then from that magnetic field we can solve, it's called the inverse problem, and then we can know what's the current inside of the thruster is. And from that we can know what's the health of the thruster, is everything right, or if something's wrong we can try to figure out from that data what caused that. And besides, we can calculate the thrust in real time.
Hall thrusters are used on satellites and interplanetary spacecraft. They're the kind of another means of propulsion other than chemical rockets. And right now there's no real-time measurement system for thrust. It's kind of like they turn them on, see how far they go, and then turn them back off, and that's kind of how much, and then they back calculate how much thrust is produced. And so what we plan on doing was we were planning on implementing a sensor array inside this thruster so we could directly correlate the plasma current that's formed from the thruster.
If you can know in real time what's the thrust of this thruster, then you can basically control the satellite better. You can do formation flying spacecraft that control their relative position.
For satellites, it's more of a station keeping. It keeps the satellite in the same place for making sure it's in the right place for orbits for communication satellites, like geosynchronous satellites, GPS and stuff like that. And then for deep space spacecraft, it's used as propulsion because it's a lot more efficient than chemical, and so it can be used on those missions that take decades. As the world moves towards this new frontier of technology and exploration and just exploring the universe, it should be quite exciting. I think we're just knocking on the door.